Okay, got that. Now, what is the unit on K? What is the unit on K? You can get the unit simply by looking at this. Give yourselves a minute. See if you can find the unit on K. You know the unit on the rate, yeah? You should know the unit in the denominator. How could you put that together? Any ideas, Michaela? Well, what should I write down for rate, Summer? Good. So we know the numerator is moles. Well, let's just go with the big M, shall we? Okay, so we know the numerator is big M over what? Seconds. But instead of seconds, can I do this instead? Mm-hmm. Can I do that instead? Yeah. Okay, good. Now what goes down here in the denominator?
Yeah, big M.
Just big M? Big M squared.
So wouldn't it be, it would still be seconds over molarity, wouldn't it?
Well, what should we do with these two big M's?
You can cancel out one,
Okay, so this goes away,
but one of them still stays.
and one of them goes away. So what's your unit for K?
Seconds over.
It's not seconds over molarity. Because really, remember I wrote this -1 there?
Yeah. So it's 1 over.
1 over molarity second. Or you could have written it like this. Or you could have written it like this. Any one of those would have been fine. Is that what you had, Brittany? Oh. Questions on how to get that unit? Because we have more of them coming.
Are they all the same?
No, they're not all the same.
Why aren't they the same?
Because the rate laws are not all the same. We aren't always going to have 2 for an exponent. Yeah, A won't always be 2. Yeah.
Could you break up molarity and like change it to moles over liters, or do you have to use the big M?
I use the big M just because the rate is molarity per second and the denominator's in molarity, so you might as well just leave them in molarity. Any other questions? All right, let's look at this problem. Oh, that's the unit of K. I got carried away again. It's just another way to look at it. Silly me, getting carried away. So, there's your unit. Got some strange things going on here. Okay, so where do we start with this bad boy? What might be a good first step? Write down what? Sure, you could do that, but that's a lot of writing. But you know what I would write down first? And what I want you to write down first? The generic rate law for this equation. Please write down the generic rate law for this equation. If you look back, we did a generic rate law on Friday, which I know was 100 years ago. What was that, Patty? Sometimes it does, doesn't it? I mean, think of all the information they've tried to cram in your heads all day and then to end it with AP.
Going from math to science is really hard.
I know. I can't wait to look at that calculus website or that calculus Khan Academy thing. Yeah. I'm going to look at that. I started to today and then I was like, no, I'm not focused enough for this right now.
Next year's gonna suck because I waited in between trimesters for
You'll be fine.
grade
Did you get this done?
I wrote down fine.
Oh, what'd you get?
I got rate equals K, the concentration of A and whatever it's going to be.
Yes. I don't know why my formatting on the bromate's all messed up. I don't either. Just go with it. Clearly, this is not the way it should be. Oops.
Sub dash.
Yeah. So how about we put a 3 here and a negative sign and scribble that out? Is that better? Okay, McFly. Now what? How are we going to find out K and the order of each one of those? Things just got really more complicated, didn't they? Actually, these are kind of fun. You ready? You ready for this? Y'all ready for this? Okay. So what you want to do is you want to choose 2 trials where you can get things to cancel out. Because if you recall, what we're going to do is we're going to take this rate law right here and we're going to put a division bar like this. And we're going to copy this whole thing down right underneath it, equals blah, 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 blah. So we got K, and we got this one, and we've to the A, and we've got this one to the B, and we've got this one to the C, right?
Yes.
And when we do this, what cancels out immediately? The K's are going to drop. See ya, bye. Don't care about you no more. Now, you need to choose any 2 of these trials that will allow us to get 2 out of the 3 to go away, to drop out.
2 out of the 3?
Choose any 2 out of the 4 that you want that will get 2 of these guys to drop out and leaving 1 remaining.
I feel like 1 and 4.
You want to use 1 and 4,
Yes.
okay?
I feel like.
I don't know which one I did, but if I did 1 and 4, what could I solve for?
You can solve for each.
Nice. Let's see, which one did I choose? I'm sure I chose something. There I did. So here I chose 1 and 2. That would have been fine, Morgan, and if I hadn't already done this, I would have done your suggestion. Okay? So what I did was I plugged all of these numbers from up here into this equation. Now, okay, the K's go away, right? And the 10 to the B divided by 10 to the B is 1, so those go away. Those cancel out. Those cancel out. Now I'm left with an equation I can deal with. Can you solve for A now? Good, solve for A. I just assumed that silence meant you were working.
Yes.
Okay, good. Solve for A.
I do not know how to work a calculator.
Michaela, did you get it?
Yeah.
What'd you get? Yep. Questions? What you doing, Caleb? Oh, you didn't have to. Any other questions on this one? Alrighty. Well, that gave us A. Huh. Wonder what I'm going to do for B now.
One that cancels out for each.
Something that's going to cancel out and leave bromine. So, which 2 do you want to use that'll allow us to cancel out the bromate ion and the hydrogen ion and leave bromine? Which 2 do you think we should use?
2 and 3.
2 and 3? Okay. Must have had a lot of time to make this PowerPoint.
Do we have to write everything down with it, or can we just go ahead?
What happened to the A? Why didn't I write A in there?
It's a cancel.
Oh, it's to the first? So that means I can ignore it when it's to the first, right? Okay, good. Just making sure. Did you get it, Pashad? Nice. Kaizen? Doing well? I understand. But, let me know if you need me to slow down. Take a look up here. Fashad, what'd you get? 1? Awesome. Patricia, did you get 1?
Yep.
You're already doing C, aren't you?
Yep.
Uh-huh. I figured as much. Joey, any questions? All right, then I guess we should go on to do C since so many others are already doing C. I chose those 2 for C. Could you have used a different set?
You can use one.
Sure. Whatever it takes to make them cancel out. Yes.
So, at the bottom,
Okay, so the third one is fine, right? This one's good? So which one should I have used down here? Since that's all messed up. All right, which one do you want to use? Or we can ignore this one if you want. You want to use 1 and 4?
Yeah.
Okay, we'll use 1 and 4. Make that go away too. See you, bye. So number 1 has a rate of 8.0 times 10 to the negative 4th, and I don't care about K, and I don't care about Br, and I don't care about bromate, so we only care about the hydrogen, right? And so that'll be 0.1, 10 to the C. Am I still doing all right here? Except I can't draw straight lines. And number 4, 3.2 times 10 to the negative 3rd, and that's going to equal 0.2, also raised to the C. Oh, goody. What do I get now? Is it 0.25? Oh, snap. Did that in my head. Zero 0.5 to the C? Wonder what C is going to be then. Take 0.5 and square it. Okay, good. Don't know what I was thinking when I typed that up. Questions? So would you please write the overall rate law for this reaction? Please combine all that stuff together and give me the overall rate. Oh, we're missing something. You can't write the overall rate law yet. What are we missing? Oh, you're missing K. Write down K. What is the overall reaction order for this thing anyway? It is 4. Yes, the overall reaction order is 4. But how are we going to find K? How are we going to solve for K? Patricia? How did I get what?
2. And that's 0.5.
Take 0.5 and square it, please. And what do you get?
0.25.
That's how I got 2.
Okay.
What is the order of this reaction in terms of bromate? What is the order of this reaction in terms of bromate? Just in terms, or another way, what you're going to read in your lab paper, it won't say in terms of, it'll say with respect to. With respect. This is a new pen. or it'll be abbreviated WRT with respect to. Meaning in terms of, so what is the order of the reaction in terms of bromate? It's a first order reaction, yes. And what is the reaction in terms of bromide? First order. And what is the reaction in terms of the hydrogen ion? It is a second order reaction in terms of the hydrogen ion. That is correct.
And overall it's 4.
Pardon?
You said overall it's 4.
And overall it's 4. So ignore the 0. The 0 is not there. Okay, so how are we going to find K?
Can't we solve for K and we equate both?
Oh yeah, I like to solve for K first, but you don't have to. Oh, don't forget, that's a 2. So what are we going to do now? Ideally, we should find the average of all of them, but let's just go with the first one and save ourselves a little bit of time. So what should we use in the numerator? I'm sorry?
Can we just write down all
Well, yeah, we have 8.4, 8.0 times 10 to the what?
-4?
Times 10 to the negative 4th. All right, so I'm going to go ahead and erase my ink. And this should be a 2 down here. So plug that in and tell me what K is, please.
I got 8.
You got 8?
Yeah.
Everybody else get 8? That's a little K. Hate this pen. Eight. Is 8 good? Is she right?
I got 8 too.
What's that for?
Because on the 4th, K does not equal 8.
On the what?
The 4, like the 4.
Oh, what did you, if you do the 4th one, what do you get?
32.
32?
32.
Everybody do this one. Do number 4.
Oh wait, I lied.
Oh, never mind.
I did the math wrong.
It happens. That, oh, it's 8. Okay, good. All right, so K is 8. Yeah, what are the units of that gonna be? What are the units of K? I need the units of K, please.
Molarity times second.
No, you have to figure it out. I need the units on K. That's a 2. That's a 2. That's a 2. And that should be an 8. So what are the units on K, please? What are the units on the rate, Caleb? How about molarity? Molarity, good. And rate is molarity what? Per second. So I'm just going to do this. Okay? Now let's look at the denominator. Okay, big M times.
Molarity times molarity squared.
Good.
And so it would be
Hold on, I'm picking on Caleb, Morgan. What should I do now? Yeah, oh yeah, that one goes away. Good. So we end up with, yeah. And another way I could have written this is,
1 over molarity squared
1 over molarity cubed times seconds, yes. Or m to the negative 3. Sorry, that should have been negative 3. Too much chemistry, you know. 3 negative. M to the negative 3. And then s to the negative 1. See, the units aren't that bad to find. You just got to break those apart. No, I don't. We're going to ignore all that because I had 0 order. So, all right. So, take a look at this reaction, please. What is the generic rate law for this reaction, please? What you got there, Blaze?
Isn't that with the exponents?
Mm-hmm.
1.
Well, that's where we do rate equals K and then the concentrations with exponents that we don't know yet.
So what's this?
That.
Oh, that, okay.
That's just called the generic rate law because we don't know any of the numbers yet. We don't know the value of the exponents. We don't know K. It's going to take this form. We know that the products have nothing to do with it, but we do know it's going to take this form. And then we can start building on it. How do we find these exponents? You can only find these by experiment. They're never
Constant.
they're never the coefficients. They're never the coefficients, ever. Okay, for the rate law. So, yes, okay, so 3, 2, 1, go.
Stays for every inch you want.
Yeah.
Go ahead and finish this, the C and et cetera.
Is there a way that you can find because you can find like the moles of each one, so you can find out how much is each.
Right.
I'm just trying to figure out in different places where I could use this.
Kinetics. And your lab. Guys, while we're waiting, take a look at your lab real quick. Because you're going to be using the method of initial rates in your labs. So this would be a good time to... The reaction order in terms of A. Why is it a second order reaction in terms of A?
Because A equals 2.
Because there's this exponent of 2 right there. Yay! Okay, so in terms of B, what is this reaction order? First. Now, in terms of, in your lab is written how?
Looking at our lab.
In your lab, in terms of, the words in terms of is replaced with a different set of words.
With respect to?
With respect to. Means the same thing. With respect to. Means the exact same thing as in terms of B. Just to let you know so you didn't get thrown on that. So yes, this is first order. Okay, what is the overall order? Summer? What is the overall reaction order for this? It is third order, yeah. How did she do that? Morgan? Adding the 2 and the 1. Yeah, good. And so the value of K, I hit enter again, was 0.153.
I thought it was 0.015.
Is it? No, it's 0.153. We need units. Who's got my units? What's that look, Brittany? Do you, Caleb? Oh, well, how would I do this, Caleb?
That's what you pick. If you wouldn't have said anything, none of this would be happening.
Molarity over molarity time.
Well, first, let's rearrange this guy for K. Let's rearrange this guy for K. Don't roll your eyes at me.
I don't know, I'm trying to think.
Okay, K is going to equal what?
Molarity?
Rate
Okay,
divided by,
concentration squared, concentration
stupid pen, A squared.
and then
Well, that should be that way. Stupid pen. Squared. And then what? Okay. So what is the rate?
is going to be molarity over molarity squared times molarity.
Well, just the rate itself.
Or molarity times
Molarity, S to the negative 1. Right? And the denominator is going to be
molarity squared.
molarity not squared. Total.
Okay, molarity over.
Yes. So what's the order going to be?
I said to the second.
Yeah. Or stupid pen. Stupid pen. Stupid pen. There you go. That's another way to write it. It says, okay. These laws show how a reaction depends on concentrations. What we've been doing with the rate laws was finding the rate based on what? Based on what? There was a method that we were using in those last problems. What was the method that we used in those last problems? It's a specific way of solving for the rate law. Look it up, it's in your notes. What method was that allowed us to find the rate law? The initial rates method. We were using the initial rates method, the experimental data, to come up with a rate law, which is what you're going to be doing in your lab. Moving on, I want to look at what's called the differentiated rate law. And the differentiated rate law depends on concentration. That part is key.
So it does not depend on time.
No, it does not depend on time. It depends on,
You have integrated and then it.
integrated depends on time.
Okay, well, you don't have differ, whatever. You don't have it at all.
Okay, well, jot it down somewhere, I'm sorry. So I guess you need to be writing this part down, because apparently it's not in your papers. Brittany,
It says differentiated rate law.
differentiated rate law.
Yeah, but,
Where are you finding it, Brittany?
On page 11.
Page 11.
We're on page 14.
Yep.
Okay, so I guess we're on page 11?
Well, that's like
No, we didn't.
all behind the problem.
no, you just
Okay.
have that picture on there.
Oh, that picture's on page 11. So I recycled the picture.
So is all that though.
Okay. Okay, thanks. Page 11. If we look at the differentiated rate law, a zero order reaction doesn't depend on concentration at all. It just depends on K. And I paused the recording because I wanted to make sure that my memory banks were still working on the calculus.
Okay.
So y equals mx. Differentiate that, and then you get the slope, m, which is what this is saying. What you guys need to know is a zero order rate law looks like that. Yep, that's what it looks like. Do you need to know that? Yep, that'd be one of those things you do need to know. The second order rate law looks like that, which makes sense because if you take it and squared it and differentiate it, it comes down to the first, right? And the second order rate law has a problem. No, it looks like that. Well, that all makes sense to me. Look at that. Zero order, the A drops out. First order, it's A to the first power. Second order, it's A to the second power. Well, this is kind of what we were doing, isn't it? It's no big deal. Now we're going to look at moving forward to the integrated rate laws. And now we're going to look how concentration depends on time. How concentration depends on time. These are so cool. How much time's left, Caleb? Okay, you were looking at the clock, so I thought you could clue me in, man. All right. Is this on your papers? So,
Yeah.
okay, so now I can go forward. We're not going to do any integrated or differentiation at all. But look at a zero order. Look at the zero order graph. Make an observation. It is linear, isn't it? Look at first order. That's not linear at all. It's curvy. Oh my gosh, look at second order. Oh, it's even curvier.
Looks like half a parabola.
Yeah, it's messed up, I'll tell you that. All right, so we're going to look at first order to begin with. First of all, we're going to look at first order. I saved zero order, I believe, for the end. Okay, so there's your differentiated rate law, aka generic rate law, correct? So your differentiated rate law could also be called the generic rate law. Where'd my pen go? Oh, there we go. Let's see if I can write.
And doesn't it have a negative sign?
Well, the negative sign is kind of maybe. I mean, you know the rate's decreasing. So, I mean, it's not like a steadfast, it's just whether you're going to write it or not. You know the rate's decreasing. Okay. Now, one thing with the differentiated rate law is, unlike the generic rate law, we do know the exponent here. What is it? 1. There's the integrated rate law.
Oh, fancy.
You do not have to memorize this. It will be given to you.
And this is what.
However, what it won't be given is I will not tell you to use this for a first order. That I expect you to know. You don't have to memorize the equation, nor do you have to know how we got there. But if you see that equation, you need to know it's an integrated rate law. And this allows us to take concentrations, see these, and base it on time. If you use the differentiated rate law to solve for K, you can use the integrated rate law to predict concentration at a specific time. What do you think this 0 means right there? Or this O? Original. Yeah, this is your original concentration. Or rather, your start. Now, interestingly enough, take a close look at that integrated rate law, and please, somebody tell me what form that equation is in. Bashad? It is in the point-slope form. What is the point-slope form of an equation? Y
equals
M X plus B. The integrated rate law puts it into a point-slope form. A is your concentration at time t. So if this is on the y-axis, t is your x-axis. K is your rate constant. T is time. A sub O is your initial concentration. Is all this on your... Okay, so here's what we have. You take all this data, concentration versus time, and you get this slopey line looking thing. Well, it's really hard to get a nice K value without calculus for this slopey line crap. But if I take this actual data and recalculating it using the natural log of the concentrations versus time, wait for it, you get this, a straight line. If I take all of the original data values for y, so if y is equal to concentration, and I get that nice curvy line I can't get a nice slope out of, but if I take the natural log of these concentrations versus time, booyah, I get a straight line.
Why is that?
It follows that law, follows that rule for a first order reaction.
I don't know what I think about that.
Pretty cool, huh?
I'm confused and kind of mind blown at the same time.
It's all right. Oh, yeah, y equals mx plus b. So I did all that for you already. We kind of already did that, didn't we?
Yes.
Yeah. Okay. All right, so here's what happens. And this is one of the things you'll be doing in your lab. You're going to run all this data in your lab. And you're going to have to determine with respect to one of your concentrations, is this first order or second order or zero order? So you will get all this data. We're going to use the probe where, boy, does that spit out data.
Office, Donovan Christian, money, come to the office.